Hello viewers, welcome to another video. In this video, I will be going to explain why transformers are rated in kVA and not in kilowatt. You can find lots of videos on this topic, but I will try to answer this question with the help of some basic concepts. First of all, we'll see what is power triangle. On three sides of a triangle, we have three different powers. On the base, we have P, which is active, real, or a true power, and it is measured in watts or kilowatts. And the formula is VI cos theta. Whereas on the perpendicular, we have Q, which is reactive power, and it is measured in VARs or kVAR, and the formula is Q equal to VI sin theta. Whereas on the hypotenuse, we have apparent power, which is measured in VA or kVA, and this is simply a product of voltage and current. And the relation between these three different type of powers is S equal to under the root P square plus Q square. It means that apparent power, which is expressed in kVA, is the sum of both the kilowatt and the kVAR. So this is the source which is expressed in kVA, and these are the types of the load that can consume kilowatt and kVAR, and we'll see these types of power in more detail in this slide, in which we have three different types of load. The one in the red is the resistive circuit, in which the angle between the voltage and current is zero, only there is a difference in the magnitude in both quantities. And this type of load consumes only the real power in kilowatts. Whereas on my right, we have inductive circuit and the capacitive circuit, and there will be a phase angle between the voltage and the currents in both types of load, and both types of load only draws kVAR or reactive power. I want to add one more information, that is, the kilowatt is the power that is consumed by the load, while the reactive power can only flows between the load and the source. This type of power is not consumed, and this is why this is called the wastage of power. But you can see that we have different types of load that can consume different type of power. Since we have different types of load that can consume active power or the reactive power, therefore a transformer which is a source to deliver the power, it must be rated in the kVA so that the consumer can know how much active and reactive power he can draw for the transformer. This is the main reason why transformers are rated in kVA, and let's clear this concept with the help of an numerical in which we are doing the power calculation for the RL load whose power factor is 58.2 degrees. So this type of load consumes 79 watts of active power and 127.5 watts of reactive power, and the total apparent power comes out to be 150 VA. So a transformer must be rated at 150 VA in order to deliver these two types of power. As the power factor changes, so does the active and the reactive power changes, but the total apparent power will remain the same. Another reason why transformers are rated in kVA are the losses. Any transformer any transformer has two types of losses: core losses and the copper losses. The core losses are based on the input voltage, whereas the copper losses are based on the current that is flowing into the windings. So the total losses only depend on the current and the voltage and not on the power factor. Since we are not dealing with the power factor, therefore both the rating of the transformer and the losses of the transformers are rated in VA or kVA. So I hope you clearly understand why the transformers are rated in VA or kVA and not in the kilowatts or kVAR, because once again the transformer is a source and the source must be expressed in kVA, whereas the loads are expressed in kilowatts and kVARs. For more interesting videos, Stay tuned and don't forget to subscribe our channel. Thank you for watching.